Okay, there you can see that. Thank you for the nice introduction. My name is Will Thomas. I'm working with Trimble in the MEP division to focus on the data mesh. So to get kind of a general introduction here, and what even is a platform team. Trimble, like you said, is an industrial technology company transforming the way the world works by delivering solutions that enable our customers to thrive. MEP is a division of that. We focus on the materials, electrical, and plumbing stage of construction. It's a variety of building cost estimation and modeling software that we've accrued through acquisitions over the previous couple decades. My name's William. Like I said, I fell in love with computers at a very young age. I started writing little text adventures like Zork, and I definitely dated myself by that reference before I could actually read. So there's a lot of copying symbols from textbooks and plugging them into the little Mac Classic computer I had. In high school, I built websites for local businesses around the area. And then during college, I built a suite of conference management software, kind of the precursor to a lot of what we're using nowadays. Moved to Colorado about almost a decade ago, and have been working with Trimble for the last 7 years. So during my time at Trimble, I started on as a consultant helping to do the initial migration efforts off of the desktop. A lot of our legacy software is desktop-based, needs to be installed, needs to have a lot of local resources, and we wanted to get things into the cloud. So during that time, it was been quite a journey, migrating these applications and kind of trying to figure out the best way to build next generation offerings. And during that effort, I found the data mesh started to come into kind of in vogue, and we've been exploring how we can use that. So right now, we're in the middle of a company-wide initiative called Connect and Scale 2025, which is an exciting goal. We're working to break down silos between the divisions within Trimble and facilitate faster, better software development, and with an emphasis on data and how we can best share our data, not just with our customers, but with other teams to kind of create new ways of putting together applications. And the data mesh was a natural fit for that. So I say data mesh a lot. This talk is not just around the data mesh, but also around kind of our philosophy around how a platform team can function within an organization and how we can evolve from just maintaining core services. Kind of a rough overview of that long-winded introduction. Like I said, I'd like to bridge the gap between product owners, developers, and DevOps so we can improve the speed and accuracy of what we're developing. One of the important things we're doing is automating our data governance needs. Data is not going anywhere, and making sure that we're building good quality data is very important to our teams, as well as maintaining velocity and accuracy with what we're delivering to our customers. We're working to accelerate development with what we call smart templates, which I'll show later. And then trying to build out a self-serve data discovery platform to foster curiosity and excitement in the data we're creating. So, slide. If anyone's ever built an event-driven application, just in general, it's a lot different than the REST-based systems that we kind of grew up building once the web became kind of the de facto platform for a lot of service SaaS offerings. You're tasked with a lot of different questions when you go to build an event-driven app in a distributed organization like Trimble, especially ones with so many legacy applications. Do you migrate the application wholesale? Do you rewrite it completely? Do you pick out little features you like and create a composite new app? Do you focus entirely on greenfield apps and sunset the legacy offerings? A lot of questions and no clear answer, because the answer actually depends on your organization and the structure they're in and the applications you're building. But we did run into some stumbling blocks that we kind of wanted to share our process and how we got to where we are today. During microservice development, we went with microservices. We thought that was the best approach, and we started with a bunch of REST-based services, like most companies do. And after a while, we found that while it was scalable to a certain extent, it wasn't good enough for what we really want to achieve. Tens of thousands of events a second, and we support a lot of concurrent users with rich collaborative UIs. That's difficult to do in REST because you end up with a lot of temporal coupling between your services, and it becomes quite fragile. And one of the terms coined is you end up oftentimes with a distributed monolith. So now you have all of the drawbacks of a monolith, a giant application, with a lot of the drawbacks of microservices, maintaining consistency and coordinating between these services. So when I accepted the architecture position in 2020, one of the first things I started looking at was event-driven applications. It's really the most future-proof way to build applications, in my opinion. That brings up a whole new problem, is how do we communicate between all these different teams? And there's hundreds of developers here, and everyone, and they're full of brilliant, intelligent people. And we found that we were starting to create these meetings that generated a lot of great ideas, but not as many action items. And one of the things we found was that ineffective communication can really delay a project. And I promise this is the last meme that I threw into my presentation. Cross-team meetings are, in general, just by their nature, expensive and not always that productive. There's a lot of different people in there. Sometimes you can say there's too many chefs. Everyone has an opinion. A lot of those are great opinions, but who do we prioritize? And where are we most effective with these meetings? Who has the final say? And how do we avoid common fallacies? Like we might have the sunk cost fallacy. What if we've been developing something for a while and it's just not going to be maintainable? When do we say enough is enough and start over? And how do we avoid the fallacy of the highest paid opinion? We get a lot of senior VPs and they have great ideas, but maybe they haven't programmed in the last 20 years. I take their ideas to the development team and it might not be achievable. So lots of discussions, few action items. How do we simplify this communication? Well, one of the ways we've landed on is schemas. Schemas that connect bounded contexts. So if you're unfamiliar, a bounded context is a subset of a domain. It's a feature. It's a certain little business operation. And usually it has a team, and that team builds and maintains that context. So how do we communicate between those contexts? Well, there's different ways to model data, and there's different tools and mechanisms we can use to formalize the communication between these teams. Some things we tried to implement some kind of key tenets between the data and how we create it. And one of them is, a team might share a command to create their data. We want commands to be one of the main interfaces between contexts. So we need a schema around that command. What does it look like? How do you view that schema? How do you submit a command that a team is going to accept and create data for you? And that same team, they own their events. They're the gatekeepers of their data. And that's a good thing. We want them to be as close to their data as possible. And there's different mechanisms they can have for sharing that. They can publish it to a Kafka topic. They can stand up an API where you can do a GET request. It's really up to them. And that's how we want to empower them. And during those meetings, we've often found that some teams were trying to convince other teams on telling them how they need to build their system because they needed data in a certain way. And that was not the right way to go about that. Because at the end of the day, who owns the data? Well, really, the customers do. Well, really, the product team does. They are the closest to the data and the customers. They're the ones that are fielding the discussions with the customers. They're the ones that are gathering requirements, and they're the ones that are finding the features that the customers will need and will want to pay us for. The engineers really just implement the data. As an engineer out there, how many times have you created fake data just to get your system running? At the end of the day, I don't really ultimately care too much about what the data is. I want to make sure that I can capture it, that I can do stuff with it, and that I can deliver something of value to the end users. This brings us to kind of a key concept we landed on is data on the inside versus data on the outside. And if you've been following the data mesh discussions, you've probably heard that term a lot. The data on the inside is where our teams can really flourish. They can do whatever they want with that data on the inside. The data on the outside, that's the sellable product. That's what we want to deliver to our customers or to our internal users as something that we have pride in. In order to kind of build this system in place, we landed on the data mesh. And if you've probably seen this graph before, if you've been following the data mesh, I copied this from Samak Dagani. She's a very brilliant person, and I hope she doesn't mind that I borrow this graphic, because it really lays out what the data mesh is and how we can use this as a philosophy for how we build our systems. And a quick overview, it's based on 4 key tenets. Domain-driven data ownership architecture. The team that owns that domain, that owns that context, they are the owners of that data. Working alongside a federated computational governance board, they are the ones that are defining the rules around the data. And this is kind of where things get a little more philosophical and less technical. They design things like general data rules, create a kind of a data glossary, and then the work of those two tenants are then fed into this concept of a data as a product. You want to be proud of your data. You want to view it as something you can sell, and then a self-serve infrastructure as a platform. And that's where my team comes in. How can we build tooling and mechanisms that can support these other three tenants? How can we deliver things to the teams and to the organization as a whole in kind of an automated way? So let's dive into these data as a product and self-serve infrastructure as a platform a little more in depth. Data as a product. So this is a kind of an obvious thing, but not really. You've been in your large organization for any long time, you'll find that data oftentimes becomes a side effect of the operation. And if you wanted to get some data from a team, it might be quite a lengthy process. You might have to go through multiple different transformations, ETL processes. You might just get a raw dump of data from a database that's, it might have value in there, but you got to mine it. You end up with these big data lakes that sometimes become data swamps. And we wanted to kind of avoid that progression and take a step back and view our data as something that we could sell, something that we have intent and purpose behind. So one of the ways that we've done that is by establishing and respecting kind of these SLAs and quality tiers. When we define our data, we want to say this data is raw data. This is just an event stream. This is the singular events, the facts that are happening within a context. You can listen to this, but there's no real strong change management, and there's going to be low confidence in the quality of the data because this is really the internal data. This is the data on the inside. And then the other two that we support are authoritative. This is the single source of truth for a domain. This is the state of that context. It might be available on a REST endpoint. It might be available through a schema-guarded topic. Something using you could view it as a state-based transfer, essentially. And then curated is a specific view into the data for one or more consumers. This has that same strict change management as authoritative, but it delivers the same high confidence that this data is the data. It's not going to change on you, and it's not going to, you can trust it. And this is important because in an event-driven world, we don't know who necessarily is consuming our data. We don't know what teams might be using. We don't know what teams are doing with it. And there could be some very central processes that are relying on our data to stay clean. We want to make sure that that data stays clean throughout the entire software development lifecycle. So as we were developing and building these schemas out and these bounded contexts, we tried a few different tools. So the first approach was to use a kind of a basic bounded context diagram. And this is available on the web. You can go to the DDD crew on GitHub, is a group of really brilliant engineers that are focusing around how do we model data. So this let us kind of start to formalize those bounded contexts, those the interfaces between different context, what you can send to a context to create data, and what you can get out of a context if you want to view something. This gave us a little structure, but it was still, it's kind of tedious. You have to fill out these forms. You got to do a lot of diagramming that might become stale, and then somebody has to go update it, and that gets kind of old fast. So we started to look around for other SaaS offerings, and we landed on this company called Onode. And Onode has been great. It's run by this brilliant guy named Bobby. He's an awesome engineer, and he has helped us a lot during this kind of transition from REST-based services into event-driven architecture. His company built a very nice system that I'll demonstrate here in a second. And we've been using it to kind of capture the high-level requirements, the events, the commands, and the view models that shape a context data. And had some nice guided sessions with Bobby. And one of the first things I did was I needed a way to capture what we're doing in this Onode modeling software and bring it into where we sit on the platform team, something that we can integrate into the CI/CD pipeline, something that'll make it easy for us to capture these requirements from the product team and from the non-technical users, so that we can create actionable items off of their design. So I'm going to show you a quick little demo here. And, I did my sacrifices to the demo gods earlier, so hopefully things won't explode on us. But if they do, hey, that's fun. Here is a little demo context, if the name wasn't, didn't give that away. I created one command in blue, one event in orange, and one of the view models in green. So the nice thing about the software is they offer a couple export functions. So I'm going to export this. This gives me a JSON file of these definitions, and then I'm going to jump over to our internal tool, which is the kind of a dashboard we built for our developers. And in here, we have some code generators, the POC of the data mesh, map settings, some cool things that help our developers serve their applications. So one of the cool things we have is these templates, and these templates are to create data products. So they fit right in with what we want to build, what we want to deliver to the teams. So to fit those data mesh principles. So I'll go over here and I will select my little data mesh demo context here. And then I will import that file from ONote. So I just export it. It's right there. And you should see down here are three models that we just defined. So here is the view model. For this one, I'd like to give it a curated quality tier. And then for our command, I'm going to give it an authoritative. This just means that there can be confidence behind the commands and the events, or in the views, so that the teams that might want to use this demo data can do so without worrying it's going to break on them. So this will kick out. This will run for a few seconds here, and then hopefully we will get a nice little download of those models that we created. So give this one more second, and I'll jump over to the next screen. Okay, so we got a download link here. And we should see in here those three models now as C# files. So we took the data we captured from ONote and generated a C# class file that we can use within the rest of the system demonstration. When we use these models, we want to make sure that they aren't going to change on us, or if they do change, there's a way to make sure that they're not going to create breaking changes. So one of the ways we like to do this is through an automated schema creation step that I'll show you in a couple minutes here. This will give us confidence that we are creating a schema that is bound to the actual state of that model, because the ultimate source of truth for the system is in the code. We don't want to have to go to another page to fill out a form on what our data looks like. We want to capture it directly from the code. This will increase the confidence in our data. We know that you can go into our Git repository, see what the data looks like, and know that because of this process we've built, this data is reflected in the reality through our system of automated governance. So one of the things we wanted to do is, like I said, not add a whole bunch of busy work. And we wanted to leverage our existing software development lifecycle, specifically the pull request. So what we did is create a couple of CI/CD plugins that we kick off when a pull request is open. The first one that I will kind of show you in a little console app here checks the compatibility of those files against what's already been registered. So these are brand new files. I'll run this application now. You should see something on my screen. And we'll see. It submitted those three models that we created, the create MEP data, MEP data, and MEP data created, and checked to see if we had any existing record of these. We didn't, so there's no possibility for the compatibility to fail, and you get a success message. Great. Well, that's step one. That'll protect our pull request and keep us from accidentally breaking things that are in the wild. Step two comes into play when we go to actually make those updates. The PR was approved. The dev team is happy with the changes. Now we want to make this a reality. So the next step kicks off during our CI/CD process, and that registers things. So let me click run here. You'll see another little console app. I'm playing the role of build server today, which is fun. And those three models are now registered. So if I go back to that dashboard, our data mesh, we should see a new context here. There it is, the demo MEP data from the data mesh domain. And there are our 3 models. So by just virtue of our little CI/CD plugins, we can capture the data that our teams are creating. And yeah, there we go. We got our MEP data. I went with the defaults here. So we get an ID and a name. But now there's a record of this data. And as during that process, which is kind of cool, we're pretty proud of that. We took a C# file, ran it through the Roslyn code analysis tools to create an internal model of what it looks like. And then we grab some convention-based information from that model to create all the cloud resources that we'll need. This is important because sometimes when you are using the SaaS offerings, we leverage the Confluent Cloud portal a lot, and Mongo and a lot of different services to host our infrastructure. Azure, obviously. A lot of this is built using Azure functions. And we wanted to ensure that we weren't creating unnecessary resources. We found that when we just opened up our tooling to every developer, if you use just the defaults, oftentimes you end up creating like production quality resources within a dev environment, which is kind of overkill if you just want to test something out. And we ended up, it cost quite a bit of money. So this lets us gate the creation of our cloud resources, keeps them in step with the model changes themselves, and governs breaking changes to those models. So one of the common questions is, well, okay, well, what happens if you have to make a breaking change? What happens if the model or the context changes so much that it's impossible to change the schema? Well, then we bring in things like topic migrations. One of my teammates, Chris Burton, worked a lot on making some cool tooling around doing automated migration so that you can move off of an older context event stream and into a new one while letting your downstream consumers know that something's going to change. And just continue to build out this kind of self-serve data platform. So here's my attempt at some soft-serve data ice cream. So I'm a big fan of sugar. The goals around our self-serve data platform and this wall of text that I told my reviewers I was going to take out, but I forgot to. Let's just read it together. You can easily view and discover data. We want to make it easy to request data exports in multiple formats. We want to ease the communication between consumers and producers of the data. We want to be able to visualize who's using your data. So, once you're tossing events out to the wild, they're just out there. People can view them. We want to know who's viewing our data. We want to know how our data gets transformed, how it plugs into pipelines. So if we have some orchestration event operations that we need to track, if there's a fault or if we need to do a rollback or something, we'll be able to do that. Because the data is stored and created using these programmatic processes, along with the governance from the data governance board, it makes it much easier to combine and view data into different ways and to create this new kind of emergent materialized views and potentially new applications we can't even envision today. And then, like I mentioned earlier, the automated cloud provision resources, so you get exactly what you need and not more. And it's being deployed and built programmatically. So if you need to tear down your infrastructure for whatever reason and rebuild it, you can just rerun those registration apps. And eventually, I want to make it so that non-technical users can request connectors, new views, and they don't need to call meetings or disrupt a sprint's philosophy to get some important information they might need for a sales meeting or some other businessy function. We also want to let the developers benefit. So the smart templates I touched on earlier, a lot of our initial DevOps and platform team work was to create some basic starter templates that fit within our infrastructure. They use our NuGets and our authentication services, but we can take it further. We can take the models that they've registered within our data mesh and create specific templates that are bound to that model using generics and some different kind of universal processors. We can make it very easy to create a producer and consumer apps directly based on what they've defined in ONode and then registered within our data mesh. And this becomes quite powerful quickly because it gives us an ability for non-technical users to create and request new data. So this is kind of cool. And it also makes it a lot more effortless to share domain models, share information between teams. You can go to the dashboard and say, I want to know a consumer app for this other team's data. I want to be able to view it. And in a couple of clicks, you're off to the races. Now, this isn't going to replace developers by any means, but this essentially serves to remove a lot of the more tedious data plumbing exercises that a lot of teams have to do. And why reinvent the wheel over and over again when we can, I mean, there's only so many ways you can capture data from a user, put it onto an event stream, and then view it in another context. So we can standardize that, which then in the future will facilitate a lot of interesting things, and that we can then, and I'll get to that in a second. I'm going to jump ahead of myself. Yeah, that was a wall of text that you probably had fun reading while I'm trying to understand me. So now let's jump to maybe a quick demo of the smart templates. So I will open up, and this one's running locally on my machine, like any good developer. I broke it before my presentation. So you'll see my console app over here. We're using the .NET new templating engine. We're a big Microsoft .NET shop, and so everything is .NET, C#, Azure function based, serverless templates, or minimum AI. Sorry, stumbled my words. A lot of coffee. So let's kick this off, and we should have a little starter app built using those data models we just registered, and just about ready to run in the wild. So open that up on another screen. Take just a second here. Okay, and here it is. We have the MEP data created. That's the event there. This takes in a create MEP data command, and has a few nice little helper functions. These are all Azure functions, so we're really leaning into serverless. We like the idea of being able to only use the resources we need when we need them. And yeah, this application is sufficient to get a team going quickly. And let's see. Yeah, that's about it for the demo. I'm not going to tempt the demo gods any further by trying to run that after I just broke things. So let's talk about what's next. Some cool things that we can do with this technology and standardizing on how we build our events and how we implement this data mesh. So some of the cool things we want to do, let me move this out of the way, is automated version updates. We want to make it so that you can, because we're building everything with really standard architecture and a lot of the data plumbing is very standardized, we can create real-time updates. We don't need to stop a team's velocity and tell them you need to update your .NET version. We can update it behind the scenes. We haven't built this yet, but this is something that we really want to do and really want to try, because updates are just constantly tedious across any organization. If we can know consistently that our applications are built consistent, we can update them in a consistent manner. Saves a lot of time and effort there. I want to support real-time curated view creation. I want a developer or a product owner or anybody really to go into our dashboard, select a couple event streams, and say, give me a view of these tables, kind of like a real-time little relational database viewer almost. They could then use those views either like as an ad hoc report, or they can create something that sticks around. Maybe it's a new event stream for another context to consume and do something cool with. And then plug that new data into the data mesh service, generate some new templates around it, and you have a brand new feature with a minimum extra work. I want to support more intelligent application health checks. The more we know how our microservices are integrated, the easier it is to ensure that we're not going to break another one by changing things or removing or adding things that might conflict with it. I think that was about it for my talk. I know it's a little bit short, but there's really a lot for us to talk about in the future, and we really be excited about hearing how the community feels about these toolings and what we can do just to bring the data mesh more into reality across the SaaS world. So thank you.
Thank you, William. Really, it was. I always expect this from architecture. I mean, because always discussing with you is like talking about philosophy in designing and developing, and it's easily recognizable. I mean, for all the guys working in architecture. Thank you very much. Really impressive, if I may say, as a non-IT field. I will ask the audience if there are questions. Please drop in the chat, and together with William, we will pick up from there. We have some nice rounds of applause. Thank you for that. Thank you in the name of William.
No, thank you. Really excited about building this. It's been a lot of fun. Hope to show it evolve as we evolve it and add more features in the future.
Really, indeed, really, as I tell. First question is coming from Flavio Bolda. Is this an alternative, maybe more comprehensive to contract testing?
That's actually, yes. We kind of want it to work hand in hand with contract testing, like Pact.io. We've been looking into that technology because integration testing and contract testing is definitely difficult, especially in the event-driven world. This might not completely replace contract testing, but rather add a further kind of a holistic view into how everything is connected and potentially allow for some more comprehensive integrations so that we could leverage contract testing for maybe our smoke testing and our deployment needs, and then use this data mesh service as kind of a more high level. I want to see how these things are connected so that maybe I can add some new connections or to remove connections. But that's a good question. I'm a big fan of Pact.io.
Also here. Thank you, William. And thank you, Flavio, for your question. Any other from the audience?
Well, if there are more in the future, my email address is william_thomas@Trimble. Feel free to send me an email, and I'd love to collaborate in the future.
Yep, and also I have to remind everybody that this audience has been recorded and it's available for seeing later. So any other questions that may arrive, please contact William via LinkedIn or via his email he just announced. We will let here also William_Thomas@Trimble.com. I have actually a question, and I don't want to let you go before putting it. This concept of owning the data is really, really, I mean, the key, especially in the governmental services offered to citizens. Is there any business model that you have already applied in such an environment? I mean, in public data owned by public institutions, and if yes, in which area?
Not that I'm aware of. There could be some high-level talks around that haven't been made public yet. I've been mostly focused on this data ownership concept between our internal teams to better reduce friction between teams, so that if a team wants to share their data, not just within our division at Trimble, but within Trimble as a whole, there's some amount of structure around that sharing and some confidence in the data that they're producing and delivering, and as well as formalizing the kind of the change management around this ownership. There's clearly defined data owners now. If you want to make changes or you want to request some new information coming out of a context, there's now a single person you can talk to, and they will help kind of kick that process off. And then my tooling is really just designed to ensure that the changes maintain that consistency, and they maintain that that quality that we want to deliver to our users. Because if we can sell or feel like we're creating data that's sellable internally, then we're absolutely creating data that we can sell to the outside world, and that we can allow some of our clients and our bigger customers in the past have expressed the desire to have a more close view of their data, and outside of the applications we deliver to them, they might want to be able to use the raw data that we're creating for their own analytical needs. And we haven't had a clearer mechanism to do that other than, it'll be in our data lake. We'll give you an export at some point.
Mm-hmm. Well, we have another question from our audience coming from BRT Dayville. Did you think that blockchain can be applied on the data and stored it into a public cloud?
That's an interesting idea. That could definitely add some transparency and security around the data that we're creating. I haven't looked too closely into the blockchain lately. I know that it's becoming less of a gambling mechanism with all the different Bitcoins you can get, and more of something that has actual value and a cool technical backing behind it. So I could see that possibly being something in the future to allow us to integrate some of the blockchain into how we generate and share our data. So that's an interesting question.
True, especially the fact that I have to say that I am a fan also of the distributed ledger technology, as we may know from earlier stages of it, because of this feature of smart contracts that could actually ease up everything around and inside and outside a community, a society, a company, and so on and so forth. Because the similarity into that with the data mesh concept that you have presented us, that you actually transform the corporate governance for data manipulation inside of the company. You already translated into a programming language, if I may say like this.
Absolutely.
It could be a very nice upgrade to be integrated based on the blockchain, definitely.
Yeah. No.
Any other questions that we have from the audience? Well, in this case, we have to thank you, William, for his presence today. Thank you, William. Hope to see you at the next edition of our event.